Okay, so let's summarize this topic, the TD learning topic. So TD learning, or temporal difference learning, means that we perform online computation of the TD error, delta value, and we use, of course, this value, the TD value, to update the Q values for the actions and states that we visit. It allows us to perform unbiased online Bellman updates without any knowledge of the model. In many cases, it converges faster than Monte Carlo approaches that we've seen before. And of course, in this case, there is no need to complete an episode. So we can also use TD learning in what's called non-episodic environments that don't start and end in a specific episode. And of course, Monte Carlo approaches did require us an episodic environment. We are required to complete episodes. SARSA, state, action, rewards, next state and next action. The first algorithm that we saw for TD learning, this is an on-policy algorithm. It is sensitive to the algorithm that we're using. On-policy algorithm. It is sensitive to the policy that we're using to interact with the environment. It provides unbiased TD learning through on-policy estimations. Q-learning, on the other hand, is an off-policy algorithm. It doesn't matter how we interact with the environment. We will learn Q star as long as we perform sufficient exploration. But it might suffer from approximation bias. But then we saw a way to address this with double Q-learning. At the cost, of course, double Q-learning comes at the cost of being less sample efficient, right? So if you remember, we used each one of the samples that we sampled from the environment, each transition, was used to update one of the Q networks and not the other. So at the end of the day, each of our Q networks is only trained on half of our samples, the transition sample. Later on, by the way, we'll see other ways to do double Q learning, which are more sample efficient, and are still effective. In avoiding the maximization bias. Finally, both SARSA and Q learning guarantee to converge to the optimal state action value in the tabular case with appropriate learning rate and epsilon decay, as we've discussed previously. Okay, what's next? Next, we're going to discuss n-step bootstrapping. So we'll start looking at solutions that perform something in the middle between TD learning and full Monte Carlo approaches, full rollouts. With respect to your assignments, please start working on tabular Q-learning, available in the course website, and implementing also the SARSA algorithm. Please check Canvas for the due date and the submission instructions. And now you should also have available a quiz for TD learning, also on Canvas. Please take that. And again, you can see the due date on Canvas. With respect to the project, with respect to the course project, please define your research hypothesis question on the domain of choice.